Assalamualaikum and hi, my name is NURUL SUKMA binti Amran. Me and my team will present about the assignment of electronic system. These are my team members, which is 8 of us. So the introduction of this assignment. Based on the assignment we had given by our lecturer, we already performed a group to the assignment about the electronic system based on the plot diagram given. So based on the plot diagram, the electronic system consists of two wein bridge oscillator circuit, active low pass filter, full bridge rectifier circuit, voltage regulator and a load. So for the result of oscillator 1, at first we have to calculate the value of the calculation for negative feedback loop and the positive feedback loop. By using the value of frequency resonance is equal to 1 kHz and the DC supply of positive and negative is equal to 15 volt. So for the first calculation is negative feedback loop. For this part, we use the formula of AB is equal to 1 plus RF over R1. So the ratio we get for the RF is equal to 2 times R1, which is we let the value of R1 is equal to 10 kilo ohm, and we get the value of RF is equal to 20 kilo ohm. So we decide to use the value of RF is equal to 22 kilo ohm to get the value of AB is equal to 3. Next is the positive feedback loop. By using the values, the equal values of R and C, we can select the value of C is equal to 1 nanofarad, and we calculate the required value of R by using the value of FR is equal to 1 kHz, and the formula is 1 over 2 pi times R times C. So we get the value of R is equal to 159.15 kilo ohm, and we decide to use the value of R is equal to 158 kilo ohm. Next, for the circuit design, we use is wein bridge oscillator circuit. So from the circuit, this one is our negative feedback loop, and the bottom one is for positive feedback loop. So for the output, we get the value of frequency is equal to 984 Hz, and the maximum voltage is 14.1 volt, and the peak voltage peak to peak is 28.2 volt. Okay, thank you. That's all from me.
Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera. I'm SAIFUL AZAHAR Mizana Abidin. Will present to you the assignment 2. My part is to design an oscillator circuit type wein bridge oscillator with resonance frequency 20 kHz and DC supply VCC plus minus 15 volt. This is a calculation for negative feedback loop. We use 1 plus R1 over R2 equal to 3. This formula to find the R1 and R2 in the negative feedback loop. Then we choose R2 equal to 20 kilo ohm, and we substitute the value into the formula, and we get R1 40 kilo ohm. For positive feedback loop, by using equal value of R and C, we select C equal to 0.22 microfarads and calculate the required value of R using formula 1 over 2 pi RC. And we substitute the value C and the frequency resonance, and we get R equal to 36 ohm. And then we design the circuit This is the circuit wine bridge oscillator, which is this is a negative feedback loop, and this is a positive feedback loop. And then this is the output of the this circuit, which is frequency equal to 16.6 kilohertz. This frequency is not fulfill the requirement, which is requirement is frequency 20 kilohertz. Then we decrease the value of R in the positive feedback loop to 29.6 ohm. This is the circuit after decrease the R to 29.6 ohm, and the output is 20 kilohertz frequency. Thank you.
I'm Taranya Alagappan and my matrix number is B08181032. That's all for my introduction. Now I'll proceed with my part, which is voltage summing. First of all, voltage summing is an op-amp circuit, operational amplifier circuit, that we use to combine voltages that present from two or more input voltages to make it to one output voltage, single output voltage. So that is why we used voltage summing in our circuit, where we used it to combine voltages from oscillator 1 circuit and oscillator 2 circuit before before further proceeding with the output voltage. So for voltage summing, as we have presented here, this is the calculation that we have done, where we have done calculation where we have summed up voltage signal from the first circuit, oscillator circuit, and the signal from the second oscillator circuit. And we have got a single output voltage, which is 28.2 voltage. And this is the circuit design for voltage summing. This is our oscillator 1 circuit, this is the oscillator 2 circuit, and this is the op-amp that we use to sum up this both output voltage and made it to a single voltage. And this is the output that we have got. So for as we can see here, the channel 1 is for output oscillator 1. Channel 2, it resembles the output from oscillator 2, and channel 3 is the resemblance of output voltage summing. That's all for my part, sir. Thank you.
Assalamualaikum. My name is HIDAYAH binti Safri. For my part, I will explain about active low pass filter. We were given some specification for each circuit. So for low pass filter, the circuit must be in second order butterworth response and frequency 8 kHz. First of all, I analyze the butterworth response table. As we can see, for second order circuit, the damping factor must 0.586. It is because the damping factor of an active filter circuit determine which is response characteristic the filter exhibits. So to achieve second order butterworth response, the ratio RA per RB must be designed 0.586. That's why RA is assumed 5x6 ohm, and then I get RB 1 kilo ohm. This is circuit that I designed. So this circuit is second order or Salem-Key circuit. For second order circuit, have two pole low pass circuit. So this is first pole and this is second pole. And for the last, this is the graph for low pass filter, and I get cut off frequency at kilohertz at this part, and this is the slope, which is negative 40 dB per decade. Thank you.
To you. My name is TARANI BASCAR and my matrix number is B0818110186. So this is our assignment, sir, and I'm here to present on my part. My part is rectifier circuit. In rectifier circuit, you have only give one specification, sir. You have only give one requirement, whereby you have said that we have to use a capacitor that has a 220 microfarad. Okay, a 220 microfarad. Okay, so this is the capacitor we have used, which is 220 microfarad, and a full wave bridge rectifier with a 100 ohm load. Okay, with a source of 20 vpk and 30 hertz of frequency. So this is our circuit, sir. And this is the calculation, VDC to VP over pi. So we get the VDC is 12.732, and also we have figured out the VP out and the V ripple. So V ripple, we got 1.721 voltage. This is a simple explanation for the calculation that we have got. Okay, now let me explain further about the output. Okay, so this is the output. This is one type of output, and this is the another type of output. Okay, so let me concentrate on this. Okay, on this, okay, what is the effect of a capacitor in a circuit? Okay, so in a circuit, when we actually put a rectifier with a capacitor, okay, what does a capacitor will do in a circuit, sir? Especially in our assignment, the capacitor is charging, it's what does the capacitor, when the voltage is rising, okay, when the voltage is rising, the capacitor will absorb energy, it will absorb voltage. So by when it's absorbing voltage, it is actually storing energy. Okay, the capacitor will store energy, so we call that, when the voltage is rising, we will call that as a charging mode. Okay, when a charging mode. So what happened when the voltage across the resistor is decreasing? So when it is decreasing, sir, the capacitor is going to release the energy. Okay, it's going to release the energy. So why does the capacitor has to release energy? Because when the capacitor releases the energy when the voltage is decreasing, it actually prevents the circuit from dropping too low. Okay, from dropping too low. And once the voltage is risen again, the capacitor is going to absorb the energy again from the circuit, so that it will prevent from it rising too quickly. Okay, it will prevent from rising too quickly. So capacitor absorb the energy and releases. Okay, it causes the voltage to be more consistent. Okay, it will cause it more consistent than falling quickly and rising quickly as well. Okay, so from falling too fast and also rising too fast, so that's how it will prevent from both of these situation to happen. So it smooths out. Okay, it smooths out the thing. So the variation in the voltage, okay, the variation, how can we see? It's through a voltage called ripple voltage. So ripple voltage is the one in the blue one, sir. Okay, it's the blue one. So the blue one is the ripple voltage. So in the ripple voltage, we can see that the wave, okay, the DC, the wave is not too low or it's not too high. Okay, it's going in a smooth line, not so smooth, but it has ripple voltage, called it as ripple voltage. So how can we reduce the ripple? How can we have a better, smoother a circuit? So how is, we can either reduce the ripple by increasing the load or by increasing the capacitor value. So the higher the capacitor value, and also we can, either one, we can increase the load, so we can reduce the ripple as well. So capacitor will cause the signal to have a smooth DC signal. Okay, sir, so this is my part. So rectifier, it's very important. Full bridge rectifier is very important in any circuit. So, and this is my part. I hope I have done. Thank you, sir. Thank you very much.
Hai, Assalamualaikum.
My name is NORAKMA binti Hassan from BEET2354. So for this assignment, I already been given to explain about voltage regulator. So as you can see on your screen, A is the calculation for the voltage regulator. So we already given the value of VL and IS. So VL is 5, IS is 0.8. So we need to find VZ. So on how to find VZ is VL minus VBT. So 5 you minus with 0.7, you will get 4.3. So to find IL is VL over RL equals to 5 over 100 is equal to 0.05 ampere. So here I assume the value of resistor load is 100. So for RS is VI minus VZ over IS. So V input we assume 15 volts. So 15 volt we minus with 5 volt and we divide by 0.8, we get 12.25 ohm. For IC is IS minus with IL equals to 0.8 minus 0.05 ampere, we get 0.75 ampere. Okay, this is the circuit design for the voltage regulator. So this is the value that we assumed just now, 100 ohm. This is the value that we get from the calculation, and this is the value that we assume, 15 volt. So we run it by using multisim, and this is all the value that we get from the circuit. So since we add the resistor load RL, we need to do the calculation to find the power load rated. So this is the calculation. As you know, the power load given is 1 watt. So this is the formula. We insert all the data that we get, and the answer is 25 ohm. So the output is, okay, here we change it into 25 volt according to the calculation that we get just now. So this is the value, 5.21 volt, and this is the value for the current is 208.429 milliampere. So to calculate the power load by using the formula that I mentioned before, so we get 1.08 watt. So that is all from me. Thank you.
Hi, sir. I'm Taranya once again, and I'll be explaining on the. I'll be wrapping up our group's presentation, whereby I'll be explaining the combined circuit, the whole circuit that we have constructed in a group, and this is our whole circuit that we have combined: oscillator 1, oscillator 2, with a voltage summing amplifier, active LPF, second order active LPF, full bridge rectifier, voltage regulator, and power with the power given. And this is, we just have divided the circuit, entire circuit, but to two parts for a better view. Just for a better view, this will be oscillator 1, oscillator 2 combined with an op amp, just to input both these output voltages into a single output voltage before proceeding to LPF, rectifier, and voltage regulator with the power. And these are the output waveforms that we have got from our circuit, with the voltage recorded, with the frequency recorded, and also the waveforms recorded in a 4-channel oscilloscope. And this will be the square waveforms with the voltage recorded, with the frequency recorded, and also recorded in a 4-channel oscilloscope. And that's it for our combined circuit. We are glad that we have constructed a full circuit and we have got the output waveforms. Thank you for listening.
Warahmatullahi wabarakatuh. My name is Abdullah Razin. For my group, I'm gonna talk about the discussion of our circuit design. From the circuit that we designed, the oscillators produce a periodic electrical signal in sine wave to convert DC signal to AC signal. Then voltage summing amplifier is used to combine the output signal from the oscillators. the oscillators that we use wind bridge oscillators to wind bridge oscillators. Then we use active low pass filter to alter the frequency response of the filter circuit by producing more selective output response, making the output bandwidth of the filter narrower or even wider. After that, we use voltage rectifier to convert the alternating current AC to direct current DC, which is required to the DC operated system. Then the output signal from went to the basic shunt voltage regulator to provide regulation by shunting current away from the load to regulate the output voltage. That's all. Thank you.
Assalamualaikum. I bid to my lecturers. My name is HILMI MUSTAQIM bin Nikmat. My number matrix is B0818-10514. I'm from BEET2/1. And today, I will present about my part, which is conclusion. At the end of this project, we managed to complete the project successfully. We're also able to run the circuit and get the correct and precise data. Data that we get are near to our calculation, so we assume that our project is successful. But there is a problem that we face during the project occur in order to complete this project. The problem that we faced was we realized that we have problem when it comes to combining the circuit at the end of the project. After having some discussion with our teams, we managed to overcome the problems and come out with completed project and correct data. That's all from me. Thank you.